Assalamu alaikum everyone, welcome back to my YouTube channel. Today we are going to discuss model textbook of physics, that is for first year of National Book Foundation, and today we are going to discuss chapter number 7, that is deformation of solids, and we are going to discuss the short conceptual question answers of this chapter. So let's get started. Moving on to the first question we have, why most of the solids prefer to be crystalline state? What is glass transition in amorphous solid? So the answer is most solid prefer the crystalline state because low energy state. Crystals have a well ordered structure, minimizing internal energy. Second is stable arrangement. Regular atomic patterns provide stability and strength. Third is efficient packing. Atoms molecules are packed efficiently, reducing structural defects. Glass transition in amorphous solids because in amorphous solids like glass, a glass transition is the temperature range where the material changes from hard, brittle state to the rubbery or viscous state. Unlike a sharp melting point, this transition is gradual and occurs in material without a well-defined crystal structure. Moving on to the next question, we have question number 2. That is why the window glasses of old buildings show milky appearance with time. So the answer to this is the milky appearance of old window glass occur due to the weathering and structural changes over time. The main reasons are micro cracks and surface roughness. Exposure to the moisture, dust, and temperature changes create tiny cracks scattering light. Next is leaching of alkali ions. The glass slowly reacts with air and water, causing minerals to leach out, leading to the cloudiness. Third is glass relaxation. Over decades, the amorphous, non-crystalline structure of glass undergoes slow structural changes affecting transparency. Next is question number 3, that is, in the elastic body, which one is more fundamental, the stress or the strain? Explain. Strain is more fundamental because it represents the actual deformation of the material, while stress is the response to that deformation. Next is the answer is strain is more fundamental because it represents the actual deformation of the material, while stress is a response to that deformation. And the definition of strain is it is a relative change in shape or size due to applied forces. Stress definition is the force per unit area applied to the body. And the third is cause-effect relationship, that is, strain is the cause and the stress is the effect. Thus, strain describes how a body deforms, making it more fundamental quantity and elasticity. Next question, we have question number 5, that is the slope of a force extension graph represent which quantity? The slope of the force extension graph represents the stiffness of the force constant of the material. According to the Hooke's law, F is directly proportional to the x, where F is the force, x is the extension, and k is the stiffness or spring constant. Rearranging k is equals to f over x, which shows that the slope f over x of the force extension graph gives stiffness. A steeper slope means the material is stiffer, require more force for its same extension, while the gentler slope means that the material is more flexible. Next question, we have question number 6. A perfume bottle or atomizer spray of fluid from inside of the bottle when it is pressed. How does the fluid rises up in the vertical tube or in the bottle? Strain energy is the energy stored in the material due to deformation of given as where sigma is the stress and epsilon is the strain, and the square term ensure positivity. Next is on which type of loads the strain energy depends. Strain energy is the energy stored in a material which is deformed. It depends on the following loads, that is tensile and compressive load, energy stored when a material is stretched or compressed. Next is shear load, energy stored when layers of material slide over each other. Third is bending load, energy stored when a beam bends due to force. And last is the torsional force, energy stored when the shaft is twisted. Each type of load deforms the material differently, affecting the amount of strain energy stored. Next question, we have question number 8. Why suspension bridges are written with their periods of use? Why after that period it is dangerous to use the bridges? So the suspension bridges have a usage period because materials degrade over time due to fatigue, creep, and corrosion. Fatigue is repeated load causing cracks in material. Creep leads to slow deformation under constant stress, and corrosion weakens structural integrity. After this period, these effects can make the bridge unsafe. The next question, we have question number 9, that is, if you want to break a wire, why we use repeated bending, how does it affect? So the answer is repeated bending is used to break a wire because it causes fatigue failure due to continuous stress and strain cycle. Effect of repeating bending is work hardening. Bending causes atom dislocations, making the metal brittle over time. Crack formation, small cracks develop at the bent area due to stress concentration. And third is fracture due to fatigue. With each bend, cracks grow, reducing the wire strength until it eventually breaks. Thus, repeated bending weaken the wire, leading to an easier breakage. Question number 10 we have, what is the significance of modulus of elasticity? The modulus of elasticity is called Young's modulus, measuring the material's ability. So that's it for today's video. If you like the video, like, share and subscribe, and we'll see you in the next lecture.